So finding the area between curves is really important because we're going to be using it a lot when we're finding the volumes of surfaces of revolution and volumes of different shapes. So what we want to do is master this so that the other stuff isn't as difficult. So I've got 3 different situations here, and our idea is we want to come up with a strategy for finding the area between 2 curves. And so here I'm just drawing I'm looking for the area between 2 curves. And so, the basic idea is that you have these 2 functions, and then remember, when you find the integral of a function, it'll give you the area underneath the curve up to the x-axis. So let's say we're just looking at this picture right here. So our general strategy is going to be to find the integral of, if you look at this, you would want to find the integral of the top function, which would give you pretty much the area all the way down here. And then you have the bottom function, and you find the area underneath that one, but that one you subtract, thereby leaving you with just the area that you're interested in. Like that. Right? So that's in this case, that's what you do. And so here, for example, to find this green area right here, we would do the integral of the top one, which in this case is f of x minus g of x dx. Now, from where to where? Well, you have to find those points of intersection, right? So you would have to actually find these. Let's call this A and B. And so to find these, you would be looking for where they intersect, or in other words, you would set f of x equal to g of x, and you would solve that equation. So actually, this is usually the hardest part. Not really the integral, but actually solving the equation. So, but anyways, now let's take a look at this one. Well, this one is, in the beginning it sort of looks like you have to do something completely different. But not really, because if you look at this, if you find the integral of f of x, you would get this area right here. And then if you find the integral of g of x, you would get this. But notice this is below the x-axis, so this area is going to be negative. So notice that if you do the same thing, the integral from a to b of f of x minus g of x, this is completely going to work, because notice that g of x is going to be negative, and so when you apply this negative, it's going to actually add it, which makes sense, right? Because you want to add this area right here, and then plus you want to add that in absolute value. So again, when you're finding the area between the curves, what you're looking for is the area in absolute value, so you don't care about above or below. And so this magical formula here just kind of works for all the cases. Now you can have some trickier situations like this, where you have 3 points of intersection. So let's call this point A, this point B, and this point C. Now in this case, notice how you can apply the same strategy, but to actually find the area underneath the curve, you're going to have to split this up. So you're going to have to go the integral from a to b, and then you would do f of x minus g of x, and then plus you're going to do the integral from b to c. But now notice that in this case, g of x now is the one that's on top, and so you would do g of x minus f of x in this, for this section of it, dx. So what we say is that in general, the area between two curves is the integral from a to b of, you're going to do top minus bottom. Okay, now the other issue that you might have, and we're going to do some examples later, is that you can have a function of y. So for example, g of y and f of y. So you can have, something that looks kind of like, let's say f of y, let's color it in red. Let's say it looks like this. And let's say g of y looks like this. And so, you're maybe not used to graphing functions like this very much, but you can also find the area between the curves here. And in this case, your integral is going to be, again, from a to b. But now in this case, your a and your b are now y values. And you're going to do right minus left with respect to y. And so because notice that when you have a function with respect to y, the positive values are over here on the x-axis. So here, for example, this f of y right here is larger than g of y. And so it's kind of like this one right here, analogous to this. This one would be the top, the right one. And this one would be the bottom, or in this case, the left one. Okay, so let's do an example. Okay, so we want to find the area between these two functions. Now, over here, I'm going to make a little line here, and we're going to write down the steps to follow. So these are kind of the basic steps, though some cases it can get a little bit more challenging, but these are the basic steps to follow. The first thing you want to do is you want to draw a picture. Now, if it's a complicated function, you can grab your graphing calculator. You only really need just kind of a rough sketch. It doesn't have to be something really fancy, just to kind of give you an idea of what's going on. So here, if I draw a rough sketch here, I would have f of x, which looks like this, and then x minus 12 is going to kind of look like that. So the area between these two is going to be right here. So this is what I'm looking for, that area right there. Okay, so once you do that, then the second step is you need to find the intersection points. Now, sometimes they're given to you, but in this case, we don't have them. So to find the intersection points, what we do is we set them equal to each other. So x squared minus 5x minus 7 is equal to x minus 12. And then we solve this. So if you bring the x and the 12 over, you would get x squared minus 6x plus 5 is equal to 0. And then we'll factor this, so we would have minus 5 and minus 1, and so then we get x is equal to 5 and 1. And you want to kind of verify that that makes sense. So here we would have 1, and here we have 5, and so that makes sense, right? Okay, and then once you find that, then you set up the integral. And this is going to be either, you set it up as either top minus bottom. That's when you have a function that's with respect to x, or you do right minus left. If you're doing it, you have a function with respect to y. So, okay, so let's do that over here. So here I get the integral from 1 to 5 of the function that's on top, which is x minus 12, and then minus the function that's on bottom, which is x squared minus 5x minus 7. And then all of this with respect to x. Okay, so then we'll simplify this a little bit. This is the integral from 1 to 5. X and then plus 5x, that's 6x. And then minus 12 plus 7, that's minus 5. And then minus x squared, all with respect to x. And so then we get the antiderivative of this. So this is going to be 3x squared minus 5x minus x cubed over 3. This is evaluated from 1 to 5. Okay, so then we just plug it in. So plug in 5. 5 squared is 25 times 3 is 75, and then minus 25 minus 5 cubed, which is 125 over 3. And then minus, we plug in 1, so we would get 3 minus 5 minus 1/3. And so then let's simplify this a little bit. These two, if I add these two up, I get 50. And then if I combine this negative 125 thirds and then plus 1/3, that's going to be negative 124 over 3. And then this is 3 minus 5, that's negative 2, so this is going to be plus 2. Okay, so this is equal to 52 minus 124 over 3, which is 32 thirds. Okay, so we need to find the area between these two functions. Now notice that you hit a little snag when starting on your first step, because these are functions of y. So you're not used to doing functions of y, and also if you're using a calculator to graph these, your calculator probably doesn't graph these kinds of functions. So I'm going to give you a really easy way to graph these. Basically what you do is pretend like these variables are switched, and you're just graphing, for example, y equals to x squared minus 5 and y equals to 3 minus x squared. These you can graph, right? So x squared minus 5 looks like this. 3 minus x squared looks like that. And so all you have to do is you basically just, to graph these, is you just rotate the entire thing, the entire axis with the graphs 90 degrees. And so then what your graph looks like is it's like this, but just flipped over. And so you have this function right here. Sorry, that one's supposed to be blue. This one is 3 minus y squared. And then you have y squared, minus 5. And that's it. So, that's an easy way to graph that one. So then your area is the one that you're looking for is right here. So then all you need to do is basically the same exact steps that we just did in the previous problem with x's. It really doesn't change much. It's just the graphing part is a little harder, but you just need to remember that your values that you're going to find are y values, and you're going to integrate with respect to y. But otherwise, it's exactly the same. So let's do the second step. We set them equal to each other. Okay, and then so we solve this. So let's bring over the y squared, and let's say you bring over the 5. So 2y squared is equal to 8. So this means that y is equal to plus or minus 2. So you divide by 2, get the square root of both sides. So that gives us these values. This is going to be negative 2, and this is going to be positive 2. So then our integral is going to be the integral from negative 2 to 2 of remember this case, it's going to be right minus left. So in this case, the right function is the one that's the larger function. So that's the blue one, 3 minus y squared. So that's going to be 3 minus y squared, and then minus y squared minus 5. So y squared minus 5. And then this is with respect to y. So notice that these two numbers, negative 2 to 2, those are the y values. And all of my variables inside are y's, and I'm integrating with respect to y. Okay, so now let's find it. Okay, so let me just move over a little bit. Okay, so then I have the integral from negative 2 to 2 of 3. Well, actually, this is going to be 3 and then plus 5. That's going to be 8. 8, and then minus y squared minus another y squared is minus 2y squared dy. Okay, so then I get 8y and then minus 2/3 y cubed, evaluated from negative 2 to 2. And so this is equal to 8 times 2 minus 2/3 times 2 cubed is 8. Need a little bit more room here. And then minus, we'll plug in negative 2, so this is going to be 8 times negative 2 minus 2/3, and then negative 2 to the 3rd. Okay, so this is going to be equal to 16 minus 16/3, and then minus, this is going to be negative 16, and then negative 2 cubed, that's negative 8 times negative 2, that's positive 16/3. Okay, so then this is going to be 32, if I combine these two, and then minus 32/3. And this is equal to 64/3. That's it. So notice how, pretty much the same. Typically the difficulty is with the graphing, but if you just use this little trick that I showed you, that makes the graphing part pretty simple, and then the rest is just exactly the same.